Okay, first recording dealing with simplifying square roots. First of all, you need to know that the expression is not in simplified form if any of the following are the case. There is a factor of the radicand that is a perfect square greater than 1, and I'll explain all of this afterwards. The radicand, if the radicand is a fraction, then the expression is not simplified. Fraction meaning a rational number where the denominator is not equal to 1. And the third possibility for it not being in simplified form is if there is a square root symbol in the denominator. So we'll look at taking care of the first problem, first requirement today, getting rid of perfect squares that are factors. So our first example, we have simplify the square root of 18. Well, over to the right I have listed the first few perfect squares. The list goes on indefinitely. 2 times 2 is equal to 4, so 4 is considered to be our first perfect square that is greater than 1. 3 times 3 equals 9, so that's our second perfect square. And 16 is the next perfect square, and 25, 36, and so forth. So we want to find, is there a number from this list, the numbers in red, is there a number from that list that divides into 18, which is our radicand? And the answer is yes. 9 divides into 18, so we can write square root of 18 as the square root of 9 times the square root of 2. Now we did that because we know the square root of 9 is simply equal to 3. And we copy down the other factor of the square root of 2. And if you put this into your calculator, 3 times square root of 2, and you put square root of 18 into your calculator, you will find that you get exactly the same answer, or an approximation for that value. So these two are equal, they're exactly equal, but 3 times square root of 2 is in simplified radical form because now the radicand is 2 and there is no perfect square greater than 1 that divides into that. Next problem, simplifying the square root of 75. So we want to find a perfect square, a number from this list that divides into 75. And the number this time is 25. So we can write square root of 75 equals the square root of 25 times the square root of 3. Square root of 25 equaling 5, we get 5 times the square root of 3 for that final answer. We know we're finished because 3 is the radicand and there is no perfect square greater than 1 that divides into that radicand. And you can check your answer on a calculator by putting in the square root of 75 and seeing that its approximation is exactly the same as 5 times square root of 3. Next problem we're going to do 2 or 3 different ways. I'll just move this over for now. Now you can find a perfect square that divides into 72, and you can start with that. Or you can search for the largest perfect square and use that. Okay, so a lot of students suggest that 9 divides into 72. 4 also divided into 72, but 9 divides into 72 8 times. So they start by writing square root of 9 times square root of 8. And that's fine. It will result in a few extra steps later on, but it's still fine. So the square root of 9 is equal to 3, and we copy down the other factor. And 3 times square root of 8 is exactly equal to the square root of 72, but neither one is in simplified radical form. This is not finished because there is still a perfect square that divides into 8, and that happens to be 4. So we write the square root of 8 as the square root of 4 times the square root of 2, and we bring down the 3 that's already out in front. And now we state the square root of 4 is equal to 2 times square root of 2 at the end and times 3 out in front. 3 times 2 is equal to 6. They're both rational factors, so we'll multiply them together. And we get 6 times square root of 2 is the final answer. Now, you could have started by searching for the largest perfect square that divides into 72. And 4 works. 4 times 18 is equal to 72. 9 is another perfect square that works, as we just indicated, over to the left. But 36 is the largest perfect square that divides into 72. 36 times 2 gives you 72. Square root of 36 is equal to 6. Bring down the other factor of the square root of 2, and you can see you end up with the same exact answer, but now there are fewer steps. But there were more steps to get started because we had to keep searching until we found the largest perfect square that divided into 72. Hope this helps get you started on simplifying square roots. Good luck.